Hello everyone. For quite a few years now, I have been developing my ideal freestyle drone frame, which I call the Tubular Quad. It is designed specifically for 6-inch twin blade props. It's a true X layout with a short fuselage and a toilet tank battery, and it is very lightweight. Most importantly, it uses tubes for arms instead of your traditional flat rectangular arms, and that allows it to be very lightweight and very responsive. So I'm currently on the 7th iteration of this tubular quad design, and this is the first version that I felt was mature enough to actually sell to you guys. So kits are available, links are in the description. However, in a previous video, I did manage to break this frame in a pretty severe crash. So in today's video, we're going to take a look at what exactly failed. I'm going to give my thoughts on how I think these failures actually were caused and ways to mitigate them in the future. And then we're going to repair this thing and get it back in the air for a little redemption rip. So let's get into it. So I've been staring at this, trying to figure out the most likely way that it failed. First off, brief recap of the arm design. It's a 12mm tube all the way to the motor, but where these two mounting screws are, there's also a 10mm tube acting as a doubler to essentially thicken the arm to deal with the higher forces at the mounting screws. There's really two ways I would expect this arm to fail. The first would be to get a break past the doubler further outwards, because where it transitions from essentially 2mm thick to 1mm thick, that's a stress concentration. Or I would expect the entire arm to fail at this outer mounting screw, because there's a huge stress concentration where all the force goes into these two screws. However, in this case, we have neither of those failures. We don't have a somewhat clean break past the doubler, and we don't have a somewhat clean break right at the mounting screw. We have this sort of delamination going on where it looks like the failure probably initiated right at the screw, but then the outer tube kind of just unglued itself from the inner tube. So to me, that looks like there was a bond failure here. And looking more closely, it really looks to me like I did not rough up the surface of this inner tube enough. Especially if I flip it over here, you can see there's like a rough patch right there, and then the rest of it looks kind of smooth. And I do remember thinking to myself, maybe I should be using a lower grit sandpaper when I was sanding all this, but I proceeded, and it looks like that maybe has bitten me, and that is probably why this arm has failed. I'm hesitant to say this whole arm design is bad, because I've had a lot of nasty crashes with this arm design, because it's been in use since the version 4 and now we're on the version 7, and I've never had a failure like this. So right now I'm gonna chalk it up to workmanship, and we're just going to replace this arm with the same design arm. And luckily I have a spare frame here which I built just to take the product photos, so I'm just gonna steal an arm from this and we'll get ourselves back in the air. And of course, the Tubular Quad version 7 kits are still for sale. Links are in the description. And if you don't want to deal with all of the bonding stuff with the Tubular Quad, there's also the Non-Tubular Quad, which has your traditional flat carbon plate arms. So let's fix the Tubular Quad. Alright, so I just got the tubular quad back together, but as I was tightening the last few screws underneath here, I noticed this little hairline crack we have going on, and it looks like it actually doesn't go through the whole plate, but I thought that was kind of interesting. And then I looked at the version 6 design, and it doesn't have the extra 2 holes here so that you can run multiple stack positions, and therefore it doesn't have that stress concentration, so no failure there on the version 6. So I don't know, maybe that alternate stack position wasn't the best idea from a strength perspective. And then I also noticed a little crack where this oddball middle standoff is. And looking at the previous version, the version 6, there actually is quite a bit of failure going on in that area. I don't know, maybe this standoff design could be improved. Not exactly sure, you know, where to draw the line between strength and lightness, because I could, you know, double the thickness of the bottom plate, but then the whole frame is going to be a lot heavier, and I kind of prioritized lightness with this particular design. But anyways, even with those little hairline cracks we're seeing develop, the fuselage is still quite rigid for the time being. I'll keep you guys updated to see how the failures progress on this design as it gets more and more beat up. For now, I'll probably just soak some thin CA into those cracks and call it a day. Let's go fly this thing. Alright, so the tubular quad is all back together. It should be flyable now. So I'm back at the spot I was last time I was flying with the backup quad, where we have these tight pine trees. So I kind of want some redemption today. Last time I crashed a lot of times and broke a lot of stuff on the backup quad. So today I want to try to get through at least 4 of my batteries, the 4 new ones, and not crash too much and go home with a working quad. So I think the setup of the tubular quad is certainly going to help with that. I'm far more used to it, and I like the low kV motors. They're 1922 kV on 4S, which gives me really good throttle control, which is really important for flying through tight areas like this. And also, the camera has a narrower field of view than the backup quad, which to me at least seems to help me judge my speed a lot better, which again goes back to having good control of the quad. So let's see what we can do. Hopefully I can go home with a working tubular quad. Alright, this is Post Flying Tim, and if you're seeing me, you know we're about to go over the post flying damage report, so let's see what we got. So nothing too major today. We had 2 props, which is to be expected. My batteries keep sliding on the battery pad, so I really need to clean the battery pad. I dinged up one of my new batteries right here because of that. And the way I mount the antennas seems to be insufficient because I keep breaking them on both the backup quad and the tubular quad. So on separate crashes, both of the zip ties that I heat shrink the antennas to broke. So I'm gonna move to at least thicker zip ties, if not a completely different mounting scheme for these antennas. And then I had a wiggly arm, which actually happened from the fasteners that mount the arm backing out due to the vibration. So I guess ideally I would put thread locker on those, but I just tightened those back up and problem solved. So nothing too major for today, but still plenty of minor things that went wrong. Overall, the tubular quad, it did fly very well. The throttle control was very refreshing, although I did crash immediately on takeoff because I thought the quad was in the air when it wasn't, just because that is how much less sensitive the throttle is on the tubular quad compared to the backup quad. But it was so much more manageable once I got in the air, and the camera makes a huge difference. I can definitely judge my speed so much better, and I can actually see obstacles a little bit better, but my goggles are very terrible, so I was still hitting tons of scraggle today. Also, the responsiveness of the tubular quad is noticeably better with that short fuselage and the toilet tank battery, so that was refreshing as well, to just get back in the air with this quad that is very responsive, very controllable. And make sure to check out the kits. I do sell these kits through CNC Drones. Check those out. They're a great way to support the channel. Make sure you're subscribed, and thanks for watching.